Hello and welcome to today's All Traffic Solutions webinar, How Intelligent Transportation Departments Can Benefit from Cloud-Based Traffic Management and IoT, the latest in our Insights in ITS webinar series. My name is Jennifer Saunders, Marketing Director for All Traffic Solutions, and I'd like to thank you all for joining us today. Before we get started, I wanted to let you know that there is a questions box at the bottom of your control panel where you can privately submit your questions during the presentation. We will have time to answer them during the presentation and some of them at the end. Also, you will receive an emailed link to the recorded presentation so that you can watch the webinar again and share with your colleagues. And now I'm going to turn the reins over to our Chief Marketing Officer, Inga Browerman.
Thanks, Jennifer. Good afternoon. I'm Inga Browerman. It is my pleasure to introduce Scott Belcher. Scott serves the President and CEO of SSB Consulting, where he specializes in transportation technology, the Internet of Things, smart cities, and the environment. Prior to SSB, Scott served as the CEO of Telecommunications Industry Association and the President and CEO of the Intelligent Transportation Society of America, or ITS America. And he's more than 30 years of private and public sector experience in Washington, D.C. Scott currently serves on the U.S. DOT ITS Program Advisory Committee, the U.S. Department of State's Advisory Committee on International Communications and Information Policy, the American Association of State and Highway Transportation Officials, AASHTO, Connected and Automated Executive Leadership Team, and the Global Actionable Innovation Advisory Board. Welcome, Scott.
Hey, welcome. It's great to be here.
All right. A little bit about ATS. I'll do our 5-second overview. ATS apologies. What is ATS? Our mission is to help build the traffic management ecosystem of the future, one that's open, flexible, and extensible, that provides the ability to manage your IoT-driven infrastructure platform as a service. And how do we do that? We really do that by 4 different ways. One is instrumenting. You're able to add any existing device to the traffic cloud and put it onto your network. 2, we communicate. You can remotely access, monitor, and manage all of your connected devices and messages from one central location. 3, analyze. We've got more insightful decisions that are based on data analytics from all your program components. And 4, reporting and instructing. You can view your dashboard, report, and instruct your devices and when many or all of your traffic devices. So that's All Traffic Solutions, and let's get started. All right, Scott, the big question. How has technology impacted transportation over the past decade?
Well, welcome from Phoenix at the AASHTO annual meeting, everybody. Please do submit questions because this is better if we're chatting together. So technology has had a huge impact on transportation already. We've seen in the last 10 or 15 years great advancements in at every level of transportation, whether it's traffic signals as we move from old digital systems that were based on algorithms to and loops, to systems that are now utilizing cameras and real-time traffic management, as we've moved from individuals kind of managing the intersections to systems that do counts and change the signals dynamically, as we've moved from vehicles that had no sensors and no cameras to vehicles that have got systems that will protect the driver, transit operations. So we've seen great movements in the use of technology that are being driven by communications and computers. Those are the 2 things that are really changing, and cameras. Those are the things that are changing transportation.
So what do you think, when you think about that technology, what do you think the biggest challenges are affecting transportation, and how can that technology be used to benefit them?
Well, it's an interesting question. I don't think that it's necessarily, the challenge isn't technology as much as right now. I think the challenge is the fact that we're losing over 40,000 people in traffic accidents every year. We had been on a super trajectory where we were actually declining the number of deaths, and then that has changed in the last 2 years, and we're now over 40,000 deaths. That's 40,000 too many, and it's unacceptable. And this is all happening at a time where the vehicle miles traveled continues to increase. And so when we look at those two things and then combine it with the fact that funding is continuing to decline, we face a real crisis. If you look at funding levels, at the national level, Congress has not increased the gas tax since 1991, and during that time, inflation has continued to drive costs up. There's been no inflationary increase, and our purchasing power continues to decline. And so we're not funding infrastructure needs that we need to, and there's really no solution in sight. Congress doesn't have the wherewithal at this point to address this because we're in a no tax environment. Some states are being more progressive, like Utah and other states that have done state gas tax increases and have linked them to inflation, and that's exactly what ought to happen. But this all affects GDP, it affects jobs, and it affects sales. So technology can help bridge some of that gap, not all of it. Technology can enable you to utilize your existing infrastructure in more productive ways and drive down the need for additional infrastructure. Give you a heads up on when infrastructure needs to be replaced and repaired. It can help you optimize the existing system. So we're going to talk a little bit about each of those as we go through it, but we are in a crisis, and we've been in a crisis. President Trump talks about a $1 trillion investment in infrastructure, but there are very few specifics. What we do know is that $1 trillion investment in infrastructure is going to be seeded with $200 billion of federal money, but the other $800 billion will come from state and local governments and the private sector. There are no specifics on that, and we also know that the one limited specific we have is that the $200 billion will be over a long period of time, but it's not reflected in the budget at this point. So states, local governments are going to have to be creative as they figure out how to fund the initiatives that they need to.
So thinking about that creativity, I think our next question really revolves around where that fits in. The trends from other industries that are making their way into the transportation field, and particularly I think those that revolve around technology and the implementation of technology to solve problems, where do you see those trends coming in? How do you see them being executed? What do you really see having an impact in the transportation field?
Yeah, this is, from my perspective, the most exciting part. I left ITS America and I went to the communications industry, because when we were at ITS America, what we were trying to do is trying to bring the legacy transportation players together with the communications industry and the technology industry to try to create synergies. So the big movement of things that you're seeing that will be making its way into transportation is first the movement into the cloud. It no longer makes sense for private companies or public operations to operate their own data centers. There's no way you can keep up with the speed of innovation that's occurring. What I saw in the telecommunications industry is rapid movement to white boxes, rapid movement to network function virtualization, which is taking routers out, which is software-defined networks, which create self-healing networks. All of these things, technology firms have a difficult time keeping up with, let alone individuals who are trying to operate centers. So you're going to see increasing movement of the data centers to the cloud and the operation, and that's a huge movement, a huge change. The second thing you're going to see is, and you are seeing, I mean, this is one of the great advances we've already started to see in transportation, is a greater use of data and data analytics and artificial intelligence. I mean, all of these things are enabling us to optimize the system, things like dynamic traffic management, integrated corridor management, transit priority. Those things all are operated off of data. And data is the new oil. And states and cities and counties, have great volumes of data, and now they've got to learn how to use it, and they've got to learn what things that they do on their own and what things that they farm out. And we talk about this whole discussion about the Internet of Things and machine-to-machine communication and smart cities. Transportation is really the poster child for machine-to-machine and the Internet of Things. And it's also leading the way in the smart cities environment, because we actually have opportunities to make cities smarter and make them operate better. And so they're kind of, I think, the beginning stages of where we're going to be going. So I see a number of really great technologies that we're going to be exporting from other industries.
So of the things that you talked about, where are the ones that you really think are exciting, and really what's going to have the biggest impact in the transportation space? Between data, between Internet of Things, how do you see all this meshing together, and really what's sort of the biggest aha moment?
Well, I think the biggest aha moment is going to be, I think you're going to see a couple of things. First of all, you're going to see DOTs avail themselves of technologies like All Traffic Solutions, Traffic Bridge, and Traffic Cloud. And what that is an enterprise, is a cloud-based enterprise platform that sits on top of the traffic management system and allows the operator to manage all of the proprietary data sets, all of the proprietary verticals as a single, holistically, and optimize their management of the traffic, of their traffic system. So what does that really mean? That means managing intersections, managing traffic flows, managing ramp metering, managing parking, managing dynamic message signs. All of those things can be managed through an enterprise platform holistically, and that's important because that's the first, that buys the states and cities and counties and transit districts time while they're moving to open and interoperable systems. And what that means is that we want to move away from proprietary hardware and software systems where you're bound to to existing hardware and you're bound to an existing vendor. That hardware and that vendor may be your solution, and it may be great, but what you want to be able to do if you're a city or a state or a county DOT is you want to be able to go out to bid on a regular basis and get the best vendor possible. And you want them to compete and give you the best price possible. And when all right, so what you want to be able to do is have hardware that you can plug and play, and then the ability to upgrade your software and have contractors who can manage it. You're also going to see, so that's one thing that I see coming rapidly. Another thing that I see coming rapidly is obviously the advent of connected and autonomous vehicles. We'll talk more about that, but that's clearly going to change the way we operate and the way we lay out our cities and the way we manage them. And then, again, we're going to see greater and greater use of data and data analytics to optimize our existing traffic management systems, to optimize vehicle systems, and to enhance safety. So there, I'll stop.
Well, no, that's a perfect point. We actually have a question from the gallery. How do you see technology affecting safety in the future? So specifically, where do you really see those impacts and where do you really see the opportunities?
Well, so I think you're going to see it affecting safety in multiple ways. If we look at the vehicles, let's start with vehicles. We've invested, that automobile manufacturers have invested a great deal of money and research in making cars safer. And so we've pretty much squeezed out just about everything that we can squeeze out of vehicles to protect you when you're in a crash, whether it's automated braking or seat belts. Now what we have to do is we have to prevent crashes. Connected vehicles will reduce crash scenarios by more than 80%. That's huge. That's bigger than seat belts. It's bigger than airbags. It's bigger than anti-lock brakes. Autonomous vehicles, when they're ultimately here, will take the driver out of the loop, and the driver is what creates the accidents. It's not the vehicles themselves. Second, you're going to see dynamic traffic signals, dynamic traffic lanes, and by doing that and managing the flow of traffic, you're going to be able to drive down accidents and fatalities. And then I think kind of even more to that is the movement to integrated corridors, where again you're managing the data from all of the inputs holistically. You've seen that deployed in Dallas and in San Diego, and you're seeing more movement towards that. I think you're going to see greater safety one example is Honda and Qualcomm now have a cell phone with DSRC in it, which allows you to protect pedestrians. Companies like All Traffic Solutions have got work zone safety applications that will send the workers a warning that there's a vehicle approaching at a high rate of speed. You've got autonomous trucks now in work zones who provide the protection that will move as the workers move and prevent the worker from actually having to go get in the vehicle, which is a primary source of fatalities in work zones. So there's a whole range of things that will drive safety. And again, I think it's going to be driven by data it's going to be driven by cameras, it's going to be driven by sensors, and it's going to be driven by data analytics.
So we've had a couple questions follow on for that. One
Sure.
is pretty straightforward. Can you explain exactly what integrated corridor management means? So I think you alluded to it, but specifically integrated corridor management.
Yep. So USDOT has sponsored a program for integrated corridor management. And so a perfect example would be in San Diego. So the San Diego region is organized and coordinated by SANDAG, which is the local council of governments. And SANDAG is overseeing all of the traffic management. And so what's happened is all of the various individual transportation organizations, the city, the county, and the state, have all gone onto a common data platform, and they're all utilizing a common data stream and common traffic signals. So they're able to manage. So what happens in many areas is you leave one jurisdiction and enter into the next jurisdiction, and you go from McCain traffic signals to Econolite to Siemens. This puts them all on the same platform and enables the corridor to be managed, and not the city, or not even the county, but the entire corridor. And so you can manage the federal highways, the state arterials, the transit district. All of those things are optimized by having a common data flow and a common data management. And so we've seen that in a number of cities, including San Diego and Dallas.
So that leads nicely into the next question that we've received from the audience, which is, how long do you think it will take for specifically traffic signal equipment to transition from proprietary to open architecture so that interconnectivity can be accomplished seamlessly?
That's a great question and an important question. I think, we still have a lot of traffic signals in cities and counties and in states that are not connected, that are not using basic technology. I mean, I think it's somewhere between 30 and 40% of the traffic signals. And so what's happening there is you simply got, the operators plugging in algorithms based on, what they know about traffic flows. And so you have the experience, and we've all had this experience, of coming to a traffic light and sitting at a red when there's no traffic going the other way. But the algorithm is set, and you're going to sit there for 30 seconds until it changes. That makes no sense whatsoever. And so the first thing is to get the signals upgraded and connect them. Making them interoperable is going to require that the cities and states demand that of their vendors, and don't buy a proprietary approach. There are plenty of open and interoperable systems out there that can be purchased, but cities and states and transit districts all are financially strapped, and they're not going to get rid of functioning systems prematurely. And so again, that's where you need to look at, you need to take an interim step to go to something like, again, the traffic cloud, but there are some other vendors that allow you to take a step above and manage those proprietary systems as if they weren't proprietary. And that's the beauty of an enterprise platform.
So in thinking about that, how did you see the DOTs making their decisions about software moving forward? So when we talk about the open versus proprietary, when we talk about the best of breed, really what are the criteria they're using to make those decisions?
So that's so I think first, DOTs, again, whether they're cities, counties, states, they need to stick to their knitting, and they need to figure out what they can outsource. It makes no sense for a DOT to manage a network any longer. They should outsource that. They can make some money doing it by renting or selling fiber, by getting, but maintaining that fiber, maintaining that network doesn't make sense. I think so. Figuring out what you do best and how to focus on that, and what other people do better and cheaper is the first thing that DOTs have got to decide and make decisions around. The second thing they need to make decisions around is, again, this whole issue around open and interoperable. Other industries have all moved in this direction. Interoperability means that that systems communicate with each other, and that other vendors can come in and take over the system. Open is another area where DOTs are really far behind, and and their vendors are far behind, and it's largely out of concerns for security. So open software development is used quite frankly, by most sophisticated industries, including the banking industry, in which they use an open platform to have multiple parties help solve parts of the problems associated with that software development. And so it's done, in a crowdsourced environment, and then the users are able to take those solutions and build it into their own problem or their own solutions. This will happen in the transportation space, and it will expedite. It makes things faster, it makes things more creative, and it makes development cheaper. And so I see that kind of coming down the pipe. Then the third thing I think that DOTs will be doing is figuring out how to leverage the assets that they have to generate revenue. So DOTs have a lot of valuable assets. In the past, we've seen situations where DOTs have been taken advantage of. They have given over data and then had that data sold back to them. And so they've been burned. But if you think about what do DOTs, regardless of whether it's transit, cities, states, or counties, what do DOTs have? They have data, the oil of the future, something that's very valuable. They have real estate. So traffic signals, street lights, fiber, those things are all immensely valuable to the carriers and to the communications infrastructure providers. And they have fiber. Again, all of those things are incredibly valuable. And the scary thing, or the reality, is we've got to think about the skill sets that our employees have, because no longer is it enough to be able to understand asphalt and concrete dynamics and loads or bridge design criteria, but now so many DOT engineers have got to be able to negotiate public-private partnerships have got to be able to manage contractors, and have got to be able to understand cutting edge applications, whether it's communications or apps or or whatever. And those are different skill sets. And that's one of the real challenges that I think DOTs face is, first, we have a shortage of engineers in this country, and then second, getting the right mix of skills is an important aspect.
That actually leads nicely into, I think, what was a great question that we received from the audience, which was, to a certain extent, are we obsessed with technology to the detriment of expanding our understanding of the specific needs of the end users?
I think they come hand in hand. I mean, yes is the answer. Let me just start there. I think it's a very perceptive question. Technology for technology's sake is never the answer. And I think, actually it's really interesting. I was just talking to somebody about autonomous vehicles, and one of the critiques of autonomous vehicles is most of Americans' commute is 19 minutes. So if that's the average commute time, how much benefit are we really going to get out of autonomous vehicles as users? There are lots of other benefits with autonomous vehicles, but as users, is that really, how much work can you get done in 19 minutes? How much sleep can you get done in 19 minutes? How much shaving can you get done in 19 minutes? Not a heck of a lot. So I think whoever asked the question, it's spot on. But if you can use technology to leverage your existing assets and save resources, and you do it intelligently, then I think it definitely makes a lot of sense. I was just talking just this morning with Carlos Braceras, who runs the Utah Department of Transportation, and either brilliantly or fortuitously, they made a decision. They took a huge risk, but they have laid fiber to all of their traffic signals in their major in the major part of the state where the vast majority of the population is, also to the rural areas. And so imagine laying fiber along in a stretch of rural highway and having to answer questions from the legislature and from the governor. And they had to do that. But now they're looking brilliant because it's that fiber that's going to enable them to service rural broadband. It's that fiber that's going to enable them to service connected and autonomous vehicles in rural areas. It's that fiber that's going to enable them to generate revenue. And so that's an example where, they took a huge risk, but bet on Secretariat, and it's really brilliant. But I do think that it's a really good caution, and we shouldn't be chasing technology for the sake of chasing technology. However, we are seeing technology really transforming the world around us. And if we don't, DOTs are behind the edge or behind the curve, largely because they're playing with taxpayer money, largely because they don't have enough money, and they have legacy systems that they've got to manage. But the questioner, I think, raises a great question.
So, and to follow on that, given the vast amount of data that are being created and the skill set that's required to manage those, do you see any conflict in how that data is going to get managed going into the future, aligned with sort of the skill sets that the current population has within the DOTs?
Yeah, again, DOTs aren't necessarily set up to manage this data. Some are. Some have invested in it. But right now, what you see is you've got an awful lot of data and not really clear on what to do with it. And there are an awful lot of snake oil salesmen out there. I mean, I think that's one of the hardest things is, you know, you come to a conference like I'm at right now, and I can't imagine how difficult it is to be a DOT employee, because you have so many people coming and telling you they've got the solution. You know, I don't know that there are any no silver bullets out there, and so the solutions are really partnerships with people, with organizations that you trust, that are forward-thinking and that know how to leverage that data. And DOTs, you know, again, can probably serve themselves well by figuring out, you know, again, what to offload to vendors that they trust. Operating a network doesn't make sense. Being in the business of doing artificial intelligence probably doesn't make sense. But being in the business of knowing how to write a contract and knowing how to manage a contractor that knows how to build you a system that will make decisions with the data that you've got, that makes a whole lot of sense. And so I think that's where the nuance is.
So thinking about that, you're speaking to a number of DOTs. When they're talking about their long-range plans, what are they talking about, and really how are they expecting to get there?
Oh, well, that's, you know, if I had the answer, that'd be great. I think, you know, I know the things I think about. So if I'm a DOT, I would be thinking about how to move my data center to the cloud and get out of that business. That'd be one thing. The second thing I would be thinking about if I were a DOT is how to make sure I've got fiber laid, and that I'm thinking intentionally about how am I going to work with the carriers to densify the network, meaning putting up small cells for wireless in a way that makes sense. The last thing that DOTs and cities want are traffic poles and street lights and other infrastructure that have got 6 radio antennas and 4 cameras on them. So you need to be thinking about what is our urban infrastructure going to look like in 10 years. So that would be something that I would be thinking about. And then I think beginning to have the conversation about how do we plan for a new environment that's built around shared use mobility, whether it's bike shares, whether it's car shares, whether it's connected and autonomous vehicles. So yesterday I flew into Phoenix, and I have to say I was stunned by how Phoenix has, you know, transmogrified its airport to meet the needs of a shared use environment, to meet the needs of Uber and Lyft and companies like that. It was hard to find where the taxi stand was, because the vast majority of people coming off of the planes were logging into Uber and Lyft. I mean, so DOTs have got to be thinking about those things going forward. You know, the biggest issue always for DOTs in actually transit districts, but in this new environment, is that last mile. So if we think about people having, in urban settings, having fewer cars, relying on different modes of transportation, how do we make sure that they have the information that they need to optimize the various offerings that the DOTs have? So those are the kinds of things I would be thinking about in terms of my long-range planning.
So I think that leads nicely into the last question, which is really how can technology be leveraged by DOTs? And just in general and specifically, what do you think the benefits are that they're going to attain?
Well, so I think I've touched on it a number of times, but it's a good kind of summary. I think, first of all, DOTs can and should leverage data that can create revenue. It can help them optimize the existing systems that they have, and it can help them integrate their various proprietary systems. So data is really the first thing. I think they can leverage the communications infrastructure, and by that I'm primarily talking about fiber. To the extent that they have their own fiber that's laid, finding ways, depending upon who owns it and in what rights of way it's placed and all of those things, and whether it's in conduit or not, that's a potential gold mine for DOTs, in the sense that you can lease your dark strands to other users, whether it's communications providers or Amazon or companies that want to be able to have their own ability to move large amounts of data. You can spin that off and reduce your costs by having somebody else operate and manage it. So I think about that. I think about, how do you leverage your infrastructure to generate revenue? And the reason I'm so focused on revenue is, if you go back to where we started, I don't see there being any new stream of revenue coming from the feds anytime soon. I don't see Congress getting the guts to pass a gas tax increase. I don't see this administration recognizing its role in supporting cities and states and transit organizations. I see what we're seeing is a movement of these things back to the local levels. So, that's why when I view things, I try to view them through the prism of how do we generate revenue. And the data that cities create, that they optimize, that they can use to optimize their system, that they can use to sell to companies like Here and TomTom and INREX, all of those things are ways for cities going forward to leverage technology and to generate revenue. And that revenue, to the extent possible, should be put back into the system. That's always the hardest part for departments of transportation. Sometimes they can be really creative about generating new revenue, only to have it go to the general fund. And so they should do everything that they can to protect it and enable them to reinvest it in transportation.
So that's all the time we have today. for Scott's presentation, but we'll be taking additional questions. So a couple of things, and I have to do the obligatory 60-second who is All Traffic Solutions again. All Traffic Solutions, really is working to develop the traffic flow as a service with real-time adaptive traffic technologies with intelligent mobility and descriptive, predictive, prescriptive analytics, really all in line to advanced road user communications. I think most of what Scott has been talking about today really is around a lot of what Scott has been talking about today has really been around the concept of open platform, which is really where we focus our energy and efforts, really looking to develop a single platform that it can integrate with any sensor into the traffic cloud and develop that holistic view of what your facility and what your environment looks like. Building out specific applications, particularly I think as it relates to DOTs with wrong-way solutions, traffic counting, calming, dynamic messaging, dynamic speed, time to destination, virtual drive times, as well as, of course, parking availability, in order to develop that really open, flexible, extensible package. So there we go. That was my 60 seconds. I think I got it in there. A couple of questions.
So while you're waiting for a question, one thing I didn't talk about, and you just mentioned it, that I think cities can also really think about, and one of the things I'm most excited about is smart parking. I think smart parking is incredibly sexy, and the reason I think it's something really to chase after is one, cities and states can leverage technology in ways to enhance revenue, to provide a great service to their citizens. People spend a third of their time in urban traffic looking for parking. If you can direct them to places, if you can price your parking dynamically, meaning you're making sure that there's always parking availability, but you're moving them around in ways that make sense. It's also a gateway into really leveraging technology and becoming a smart city. All Traffic Solutions has got an interesting smart traffic or smart parking solution that I kind of like, but to be perfectly honest, I like most smart parking solutions. I
Can't
do
go wrong
think
with smart
that,
parking.
Yeah, and yeah. So why don't you go to the other questions you have?
All right. So I was going to say you jumped the gun there. We have a good number of questions that have come in. So a couple of things I think that align to what you just said, really, which is around sort of smart transportation systems really have focused around sort of large implementations, so either cities or large motorways. Really, where do you see lower cost ITS supporting smaller roads in urban centers, not just sort of I take it back to parking, but also to all of the other ITS areas that we've discussed today?
In urban areas, did you say?
So the focus has been in urban areas. Where do you really see the implementation having an impact in lower cost, smaller roads, urban centers, or smaller, less urbanized centers?
Oh, in rural. Yeah, no, that's a super question. Like I said, I think what Utah's done in pulling cable is one of the most brilliant things, because one of the hardest things for urban areas is connectivity, and so all of these solutions are all based on connectivity, and the carriers have a difficulty rationalizing the investment in the telecommunications carriers have difficulty rationalizing the investment in rural areas, and because there's just not enough return on their investment. And so without that connectivity, a lot of these solutions can, in fact, be challenging. there are a number of really interesting solutions that I've seen around in rural areas. I mean, first of all, if you can utilize utilize some basic data analytics to identify where your highest traffic fatalities or traffic crash areas are, that can enable a city or a county to really focus its resources in the high interest areas. And then with that, then you can use technology well. I mean, so there are a lot of technologies around providing information either to dynamic message signs or to lights around weather changes, around traffic or immediate traffic changes. I think utilizing new routing systems like Waze is one I particularly like, can be very beneficial in rural areas. Waze, the difference between Waze and some of the other traffic routing systems is it is crowdsourced, and so to the extent that there's somebody who's driving down a rural area and there's a crash that's just occurred, or somebody's hit a deer or something, they can communicate that to the rest of the network, and you can get real-time information in ways that you often don't get through other advisories. The other thing I like about that, about Waze, and those of you who have kids can relate to it, is it also has a gamification edge to it, and so the kids want to play the game, and they get points for going on different routes or taking the Waze route, and that's the only traveler information system my kids will use. I've seen some really interesting applications as it relates to lane crossings that can be done cheaply and effectively, with sensors and just signaling. And then you're starting to see some really great and effective technologies with train crossings. Again, all of these things are relatively low cost, and they're opportunistic. And I think in rural areas and less urbanized areas, that's what you've got to be. Is you've got to really be opportunistic to drive down fatalities, because the revenue is just not there to build out the sexy applications that you can do in urban areas.
So speaking of the sexy applications, I think one final question. Where do you see how DOTs manage the somewhat inherent conflict between the sexy applications that can create silos between the longer, with the longer range, building the ecosystem or building the system or infrastructure that will help them get to that next level and get to their fully sort of autonomous platform management. How do they manage that sort of natural dichotomy between the two of, siloized applications yet building out the long range plan?
I'm going to sound like a broken record. It's really, I think, as DOTs move forward, they have to be thinking about these applications in a coherent, coordinated manner, and they need to make sure that they're buying hardware and software that's interoperable, that can interface with other systems, that can operate on a common data platform, that can, that you can plug and play as technology continues to advance, and that they're not buying into proprietary silos. Because, you're right, things are going to change. Who knows what's going to happen, for example, with connected vehicles in 5.9. I still feel like we're going to see 5.9 deployed, but again, I think it's going to be deployed probably more opportunistically, because I'm not sure we're going to see a regulation mandating it. And so, how does a city or a state protect themselves there? They protect themselves there by making sure that they have connectivity to their traffic signals, they have power, and then if 5.9 isn't available, at least they have the necessary infrastructure to accommodate what will be available. But more importantly, as they're thinking about, getting or buying a 5.9 infrastructure transponder, or buying a small cell, or allowing people to deploy those on their infrastructure, I would make sure that whatever I did had Bluetooth, had Wi-Fi, had 3G, 4G, slots for 5G whenever that's defined, has 5.9, all in it. And those radio sets are available, and that way you're there ready for whatever it is, and have enough slots so that, the things that we don't know about, make sure that you've got the infrastructure and the capability to accommodate them, and the openness to do that. I mean, that's really, and that may be easier said than done, and I understand that, but I am seeing companies out there, again, making small cells, making transponders that have multi-protocol readers in them and have the ability to, and that are prepared for the advent of 5G that can accommodate 5.9. So that'd be the way I would think about it.
Okay, thank you. So ultimately, future-proofing yourselves by giving the maximum flexibility at the same time you're building out that ecosystem.
Yep.
All right. All right. Well, thank you, everybody, so much for attending. That's all the time that we have for today. I'd like to thank you for joining us, and you can contact All Traffic Solutions or Scott, even at Scott's contact information is on the slide in front of you, or you can contact All Traffic Solutions at our website, alltrafficsolutions.com, and to find out more information about open, extensible, flexible platforms. That concludes today's broadcast, and again, thank you for attending.